In this video, we'll cover something called series circuits. When you look to this shape, or this diagram, find something look like that here, 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 and here. Something different it is here. So this is DC supply, which is battery, and this is the positive side. The thin one is the negative, so we have two sides. The tall one, or the long one, is the positive, and here is the negative. So the current is going through this line, going through R1 and through R2, then it's going through R3, and this is R4. This is the value of the resistance, and this is the value of the DC supply. First, what is resistance? Resistance is everything consume electricity, and then while doing that, it resists the current. Okay. So the first question is, how we know this diagram is series, not parallel circuits? It's a series circuits. Because we have one circuits. You see, this is one. If you go like the blue arrow, it will be one circuits. If we have more than one circuits, it must be something called parallel. There's another question is why we need to learn how to solve series. Series is needed if there is component. We need them to use different voltage, like you see VR1, the voltage in R1 will be different than the voltage in R2, and the voltage in R2 will be different than the voltage in for VR3 or for the R3, and VR3, the voltage for VR3 is different than VR2 4. Yes, it might be similar, but usually we use it for different one. Also, we use it because at the same time we need the current will be common for all these components. R1, R2, R3, R4 are using one I, which is the current. So in this case we need series. Now, what's the typical question? The typical question, most of the teachers, they will ask about VR or R or E, and they will try to avoid asking for the current, the common current, let's say, because it's going through all this resistance. Why? They want you to use the feature that all of them, they have one common current. Okay, so let's see, this is a typical question. What is the voltage for R1, or they call it, what is VR1? So in this case, we don't know the currents going through R1. We know the resistance for R1. So first we need to find the I common or I total, or the I going through all this resistance. How can we find it? By using Ohm law. Ohm law equal V divided by R, equal I. But in this case, because we have more than one R, so we are using something called R total. So what is R total? And what is V in this case? In this case, V equal E equal 20 voltage, of course. You see here, this is the value. If we have more than one voltage, it depends about the direction of the voltage. If they have the same, we will sum them. We will add them together, and if they are in different direction, we will subtract them. Anyway, let's assume they are 20 in this case. So what's R total? Because it's series, and this is why we are focusing about series, we'll add all the resistance together. So R1 plus R2 plus R3 plus R4 will equal R total. So R1, R2, R3, R4. If you add them together, 4 plus 6, it will be 10. 10 plus 2, it will be 12. 12 plus 8 will be 20 ohm, because this is R. So we use 20 and use this equation. By using this number, we'll find this one. I equal 20 over 20, or 20 divided by 20. It will be 1 ampere. So what's again? What is the I? What's 1 ampere? It is the I going through this circuit. So the question is again, what is VR1? VR1 in this case will equal I multiplied by R. Or sorry, I multiplied by R, because we are using Ohm law. So we are using the voltage. So we are using the currents going through R1, which is 1, and we multiplied by the value of R1. So this is 4 ohm and this is 1 ampere. 1 ampere multiplied by 4 ohm will equal 4 volts. And this is what they call VR1. This is the voltage between this point to this point. And as you can see now, R1 and R2, they have one common point, which is here in this red line. They don't have any other common points. So that's why R1, R2 are series, not parallel. And again, you see R1 and R3, they have one common points, not two. See, the second point here is shared with other resistance, while the first area for R2 is shared with R1. So how can we check if this answer is right or wrong? We can do the same for VR1, for VR2, VR3, VR4 plus VR1. If they are 20, which is equal to the source, it means it's checked and it's right. So what's about VR1? VR1 will equal I, which is because I is common for all, which is 1, multiplied by 6, which is the resistance. This one will equal, VR2 will equal 6, and it's the same, not the same number, but the same way we can solve all this, and it's checked. Sometimes they ask about the power for R1, and we know the law for P is I squared multiplied by R, or we can use VR squared divided by R1, or we can use I multiplied by VR1. So in this case we can use any one. So if we use 20 here, because sorry, we are using V, sorry, we are using 4V because this VR1, we are using VR1 divided squared will be 16. 16 divided by 4, which is R1, 16 divided by 4 will be 4. So it is 4. And we can use, it's again like, so it's 4 watt. Sorry, PR1 is 4 watt. We can use I, which is 1 squared, which is still 1, multiplied by R1, which is 4. So again, we are making sure that it is 4 watts. And we can do it for R1, R2, R3, R4 to find the P, R2, P for R3, P for R4. If we find them together and add them together, it will equal the total power that it's been done by E20 plus I, because it's common for all, plus R total, which is this one. Thank you for listening. Have a nice day.